3 is talking about data collection and sampling techniques. So in objective 5 here, we're going to identify the 4 basic sampling techniques. So data can be used to describe situation or events. Data can be collected in numerous ways. The most common is surveys, such as a telephone survey, mailed questionnaires, personal interviews, observations, or reviewing records. Hmm. Researchers Researchers use samples to collect data about variables from a large population. So again, we're going to take a sample because again, we can't observe 100,000, but maybe we take a sample of 1,000 from earlier. However, samples cannot be collected haphazardly because the data collected might be what we call biased. We want to try to do our best on randomly selecting people and not just selecting the people that we want to select. So to obtain an unbiased sample, that is samples that are given, each subject is given the same in the population, a equally likely chance of being selected. So again, if you want an unbiased sample, every person in your population has the same opportunity as being selected. That would be an unbiased sample. Likely chance of being selected, statisticians use 4 basic methods of sampling. You have random, systematic, stratified, and cluster sampling. You need to know these 4. So let's break them all down. We'll start off with the best and go down to the worst, is what, in my opinion. Random sampling is the best. And again, so again, this is just random sampling. And they are selected by using chance methods or random numbers. So basically, let's say you have 100,000 people, you give them all one number, one out of 100,000, and then you randomly select a number out of 100,000. So every person in that population had an opportunity to be selected. It doesn't really matter how many you select, but it's the fact that as you were selecting them, they all had the same opportunity. So again, what they're saying here is one method is to associate number cards with each item in the population, mixing the cards, selecting all the cards needed. Another is to select the numbers, such as for lotteries, by mixing balls marked with possible numbers with forced air and selecting the one that rises to the top. So if you have 100,000 balls, you can do it that way as well. Um, Other ways is we can select a coin. We can flip it. Let's flip it 5 times and record it heads or tails. You could do this on a phone. I'm just going to Google a flipping a coin. So flip a coin, and Google will literally do it for you. So it flips it. First round, we got tails. All right. So I'm going to go tails. I'm going to flip it again. And I get tails again. So again, every time I flip this coin, each side still has the same opportunity of being selected. So I flip it again, and I get heads this time. I flip it again. I get heads again. And we'll flip it one more time. And I get heads for a third time. So how many heads did I get? We got 3. How many heads did 5 of your classmates toss? Well, we don't get that opportunity here, so we won't be able to answer this question. Were they the same? Who knows? Flipping coins is just an example of a random experiment in which y'all could have looked at data. So some of y'all, if y'all are watching this video together, definitely attempt that and see how if y'all were close or not. Over time, if I was to flip this coin infinitely many times, I should get the same amount of tails as the same amount of heads since I have a 50-50 chance there. And we'll talk more about what that means in a later chapter. So populations are often too large for the previous method. So random numbers are generated using a computer or calculator. So examples, suppose the company for which you work has 983 employees and your department needs a sample of employees for a study. You have determined that the sample must have at least 842 subjects. So a sample of 842 numbers between 1 and 9,863 without repetition could be generated using a computer random number generator. And the employees associated with the selected numbers would be in the sample. Now, I'm not going to make y'all do that. So what we're going to do instead is I want you to use either the 83, 84, or the Inspire, and we're going to generate 10 random numbers between 1 and 85. So this is how you do it. Just go to regular calculator if you are on your Inspire. Let me make sure it's still sharing. Okay, perfect. And so what we'll do is we'll just go to menu. We go to 5 for probability, and we want to do a random number. What we do here is kind of the same concept as what they're doing here. Probability. All we got to do is we have to list our how many numbers we have. So 1 to 85 in the situation. And that third number would be how many am I choosing out of those different ones. So we'll go 1, comma, 85, comma, 10. Ooh, I put a decimal or something. Hold on. Select the wrong one. Maybe it's sample. Yeah, there it is. Random sample. Sorry. So 1, comma, 85, comma, 10. Come on. Hold on. We'll get this figured out. Maybe random integer. 1, comma, I guess that's what they are. There we go. Okay, so random integer is what we need to select. And then again, so as you can see, everybody in the 85 people I had all had an equal opportunity to be selected. And these are the 10 people I'm going to select for whatever survey it is. So this will be a random, unbiased sample and one of the best ways to do it, in my personal opinion, and the opinions of a lot of statisticians. All right, so again, this just kind of explains how to use it. So we use the right arrow on the calculator to see the rest of the randomly selected numbers. On mine, I was able to see all 10. If any occurred more than once, repeat the procedure to generate as many more randomly selected values as needed. So if I would have gotten here and I got a double here, I would have selected it. Let's say this 44 and this 4 was also a 44. I would take my 9. I would randomly select another person that's not part of that 9 to replace the repeated number. All right, so that's how you would do again, because this thing does repeat. So you would just do it until you finally get 10 non-repeated numbers. And you don't have to do 10 on the next one. You could just do one random number. Historically, before computers were available, random numbers were selected using tables. So we just put all the numbers on a piece of paper, grabbed one, and then that was the first one. Again, this is just using the random number table to select 10 from a population of 85, which is what we did. And here are all the different random tables selected. Right? And these are just, again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then we had all this right here. And these were all the random tables. So what they would actually do, and so before technology, is they would have all these numbers as randomly as they possibly could. They would close their eyes and go, this one. And I landed on 35. So I'd write 35. And then I go, this one. And I landed on 48. So I write that thing down and I go, this one. And I'm not even on the paper, so we'll say 34, right? And that's how they randomly did it. It's still probably a little bias maybe in there if you have any of the numbers memorized and you're trying to avoid a certain number. But that was their best way of randomizing the possibility of all 45 numbers, is again, they would randomly point with their finger on the table. And whatever got closest, that's what they selected. And we did this until we had 10 numbers. And then you go to the next column and continue the same process with your neighbors and stuff like that and see, all right, what out of these random ones, who are we all selecting? So that was what we do back in the day, but now we got technology. So that's what I'll kind of expect you to do. I want to expect you to write 85 numbers and then close your eyes and pick one. All right, the next sampling is what we call systematic samples. One of the biggest questions I always get when we talk about these different samples is, if random is the best, why don't we just do random? Sometimes that's not the easiest process. There are easier process, but there is some bias to it. So systematic samples are just random samples obtained by numbering each subject of the population and choosing every kth subject. The first subject is selected by random by choosing a number between 1 and k. Then every kth subject is in the list is also selected. So for example, let's say I have 100 kids in here. I want to randomly select 10, and I want to randomly select the 8th person. So that means I randomly gave them all a number, but now I'm going to personally select 8, 16, 24, 32, 40, and so on until I get all 10 of every number that was ranked the 8th term every single time. So it's random in a sense that the first number was random, but then after that point, it was pretty much self-choosing. So if I randomly choose this number, these 10 numbers will be chosen. So it's random in a sense, but can still be kind of biased in a sense as well. So systematic sampling has the advantage of selecting subjects throughout an ordered population. This sampling method is fast and convenient if the population can be easily numbered. So again, suppose there's 350 subjects and I want 35 as needed. So I'll divide that by 350 divided by 10, and I'll randomly select the number 1 through 10. So what we'll do first to kind of go through this example. So we'll randomly choose a number between 1 and 10. So here we go. So I'm just going to like to copy and paste 1 through 10. I just want one number, and we got 8. So that was just an example. So here we go. So we used our calculator, and we got 8. This is the first subject. So the sample includes the first 8 and each of the following by adding 10, right? So that's going to be 8, then 18, and then 28, and then 38, and so on and so on. We would be here for a while if I list all those, right? Because how many we wanted? A sample of 35 is needed. So this will be a while, but I would keep doing that until I had all 35 numbers. All right, the next one is what we call a stratified. This will probably be the last part of this one because I actually have another class I need to go teach, but then I'll finish this chapter in another video to give you multiple ones to read as well. So for now, I think I'm going to pause it here. It's a good stop because I have to transition into my next class. All right. So there will be multiple videos for each week just because there's just so much to cover. I'll see you in the next video.